Professor Mr. K. Balraj is working as a polymer consultant and teaching fellow in the area of polymer science and engineering at CEG Anna University, Chennai. He has completed AMIE in electrical engineering at the Institution of Engineers, India, Calcutta, and MTech Polymer Science and Engineering at CEG Anna University. He is also pursuing his doctoral research work in polymer technology. His area of specialization includes polymer rheology, polymer processing, characterization and testing of polymers, polymer blends and composites, and insulation technology. He has in-depth experience on plastic properties, testing methods, and the relevant standards. He has more than 15 years of teaching experience in polymer science and engineering, including instrumentation in polymer industries, engineering plastics, conducting polymers, and rubber technology at CEG Anna University. He has guided more than 30 MTech students in their research projects. He has presented more than 20 research papers in the national and international conferences in the area of polymer science. He has published 10 research papers in the peer-reviewed journals.
Welcome to UGC lecture series in polymer science. In polymer science, the course is polymer processing and mold design. Today's episode is part 3. In the last two classes, we have discussed about extrusion molding and injection molding. In today's class, we will discuss about reaction injection molding, which is again a variation of injection molding, and why we go for reaction injection molding. And then we will also look into another important polymer processing operation, which is blow molding. In the blow molding, there are three types. One is extrusion blow molding, injection blow molding, and stretch blow molding. We will see one by one. First, what is reaction injection molding? So, in reaction injection molding, two highly reactive liquid ingredients, normally we take two different monomers. They are mixed and immediately injected into a mold cavity, where chemical reactions would take place that will ultimately result into solidification, and you get a product. Why we want to go for reaction injection molding? Because injection molding, almost any product, plastic product could be prepared by injection molding, then still we need to go for reaction injection molding because of these reasons. One thing is, the size of the article to be molded increases, there will be two principal problems that will arise in the injection molding. One is generating enough homogeneous melt in the injection molding machine. As the product size becomes larger and larger, then you need to melt more and more resin in the single screw extruder. So, therefore, the barrel size is going to increase, and correspondingly the heater elements that is required will increase. So, that will ultimately increase the cost, and not only that, the increase in temperature would also result will affect the rheological properties of the polymeric melts. So, therefore, this is one of the serious issue with respect to the size of the product in injection molding. The other one is to maintain the sufficient clamping pressure or the clamping force to keep the mold closed during the filling and packaging stages of the injection molding operation. In the last episode, when we have discussed about the injection molding, the injection molding machines are normally, the rating is in terms of tons, 250 ton injection molding machine or 50 ton. So, this tonnage directly refers to the amount of clamping force it could generate, because once the mold is filled with the resin, the mold has to be tightly closed, still the product gets solidified, and ultimately it is removed from the mold. So, therefore, still then you need to apply the clamping force. So, the size of the particle is high, then one has to maintain the clamping force for that much time. So, that will ultimately increase the cost of the machine. So, to overcome this, we go for the reaction injection molding process. So, in this two or more low viscosity in the range 0.1 to 1 Pascal second liquid streams which react when they are brought together, and also there is a mixer that is there that will ensure that these two liquid streams are mixed thoroughly before it has been injected into the mold cavity. As the reaction injection molding machine is mainly meant for large sized particles, the cavity would also be of large size. So, this is a typical scheme representing a reaction injection molding. Here I will have two tanks that is well agitated, in which you will have monomer 1 and then the another one is the monomer 2, and then you have a pump to control the flow rate of this, and then you do have heat exchangers to maintain correct temperature either during the mixing operation or when it is injected into the mold. And also you have displacement cylinders to adjust the rate. Normally we have a ratio control here. That means what is the ratio of monomer 1 to monomer 2, that ratio could also be set in the ratio control. So therefore these two liquid streams are mixed in this thoroughly and then injected into the mold. So this is a typical scheme of reaction injection molding. Now during the process, what happens is some of the polymerization reaction will occur during the filling stage, that is when the mixed liquid systems, that is monomer 1 and monomer 2, they are thoroughly mixed in the mixer and then it is filled in the mold. It takes some time because the cavity of the mold is large. So therefore the filling takes more time, and during the time itself the polymerization would start. This would also result in a linear or a branched or a cross linked polymer. Now the bulk of the reaction, however, takes place only after filling. Only when the filling is complete or the mold is filled to the fullest level, then only the remaining polymerization reaction will occur, and also it will even continue even after it is removed from the hot mold. Hence the injection pressures needed for filling molds in the reaction injection molding process are generally small. So earlier when we defined what is injection molding, in the injection molding is simply nothing but injecting liquid resin into a mold at a high pressure. That is the basis of normal injection molding process. Therefore the pressure has to be kept very high because that will only ensure the resin filling uniformly in the mold, whereas in the reaction injection molding the injection pressures need not be very high, so are generally small. Now as the polymerization proceeds after filling, heat is generated by the reaction, which will actually increase the specific volume of the polymer system. So therefore the mold design has to be taken into account accordingly, and also you have displacement cylinders that may absorb the extra monomers that are unable to fill the mold. Now looking into the materials for reaction injection molding, the most commonly used polymer system is that of polyurethanes, either in the form of linear or in the form of cross linked. The polyurethane is prepared by reacting alcohol, that is diols or triols, with isocyanates. So these are the two different monomers or the starting materials in the preparation of polyurethane. So that is polyol plus isocyanate will result in the polymer polyurethane. So the one important requirement in the reaction injection molding is you have to choose a polymeric system wherein there is no volatile byproducts are formed, because the mold will be closed. If at all any volatiles are going to form during the reaction, then that will cause formation of voids in the product. Therefore one has to choose a polymeric system in such a way, once the as and when the polymer is formed from the monomer to polymer, there should not be byproducts in the form of volatiles. So normally a diol with 2 OH groups or a triol with 3 OH groups, which is normally present in polyethylene oxide or polypropylene oxide chain, and then isocyanates, the methyl diisocyanate is the most common. So the presence of this isocyanate group, 2 isocyanate groups, that is why it is diisocyanate and methyl. So these are the common starting materials that are used in the reaction injection molding process, and chief polymer is polyurethane. Nowadays the fiber filled polyesters also have been used. Apart from polyurethane, nowadays more and more number of engineering grade polyesters are available. That is possible with varying the fiber content in the polyester resin. The other systems also include polyureas. Nowadays nylon 6 has also been tried in reaction injection molding, polyesters, polyacrylamides and epoxies. So thermosets could also be used in reaction injection molding process. Now if you compare this reaction injection molding process with the conventional injection molding or thermoplastic injection molding, if you look into the temperature, so the temperature is the main, the temperature of the reactants as well as the temperature of the mold. So normally the mold temperature is kept at temperatures that The mold temperature is normally kept at the temperature the Tg or Tm of the polymeric system. Now, if you in the reaction injection molding, the reactants need not be at a high temperature. For 40 degree Celsius itself is enough, whereas in conventional process it will be around not less than 200 degree Celsius, that too the melt temperature of the polymer. And then the mold could mold, but then here the mold has to be maintained at a relatively higher temperature, that is at 70 degree Celsius, whereas in thermoplastic it is 25 degree Celsius, because in the here it has to be allowed to solidify. The cycle time for a thermoplastic injection molding is less, so therefore the cooling time available would be less, therefore it has to cool fast. Therefore, the temperature would be maintained at a very less value. Now, if you look into the viscosity of the material to be considered, the 1 Pascal second will be the viscosity in the reaction injection molding, because you normally take in the form of a liquid resin, whereas in the conventional injection molding process it is around 100 to 1000, therefore more than 1000 times higher viscosity materials are used in conventional injection molding process. So, therefore, it has its own issues related to the rheology, that is if the viscosity is going to be very high, then the polymeric melt flow system would not be uniform, or in other words one has to increase the speed of the screw, and the screw efficiency is has to be maintained at a very high value. And with respect to the injection pressure, in the reaction injection molding 100 bars of pressure is sufficient for the mold to be at the closed position, whereas in the conventional process it has to be more than 10 times that of the reaction injection molding machine. So, a minimum of 1000 bar pressure is the pressure at which the resin has to be injected. Now, looking into the clamping force, 50 ton would be more than enough for any reaction injection molding process, whereas in the conventional system it will go up to 3000 ton. So, all these forces are required for 1 meter squared area of the surface. Now, looking into the advantages, as we have seen, the low viscosity is the main advantage here. Therefore, large pots with the thin sections would not be issue in preparing such products, and also incorporation of fillers is relatively easy compared to the conventional process, and then no regrind is required, that is no post finishing operations are required in a reaction injection molding process. And also in a normal injection molded product there will always be weld lines. The weld lines are the nothing but the surface irregularities on the final product. So, here no such weld lines would be formed. So, despite that there are some drawbacks with reaction injection molding. One is with respect to the mixing. If the mixing is not thorough, then the ratio at which we want to mix the monomer 1 and the monomer 2 will again is going to affect the final properties of the polymer as well as the product. So, therefore, the incomplete mixing is one of the main issue, and the mostly polyurethane is the polymer that is used in reaction injection molding process, where the isocyanate is the important component, and also it is toxic. So, therefore, the environmental issue, and then chemistries are limited to those that form cross links without a volatile byproduct. So, this is the other thing. If you look into any type of resin or any type of monomers, when you react to monomers, then generally there is a byproduct. Sometimes water is the common byproduct for most of the reactions. So, therefore, if one starts eliminating likewise, there you will be left alone with polyurethane. So, therefore, that is again a drawback with respect to reaction injection molding, and there is no way to recycle the thermosets. So, it will be completely cross linked product. So, therefore, one cannot go for recycling. So, these are the drawbacks of reaction injection molding. So, the another variation of reaction injection molding is nothing but the reinforced reaction injection molding. So, in this process dry reinforcement means nothing but a fiber, either in the form of a chopped strand mat or woven fiber. So, likewise fibers are available in different forms. they are generally called as preforms. That means it will have specific shapes, is placed in a closed mold. Next, a reactive plastic system is mixed under high pressure in a specially designed mixing head. Upon mixing, the reacting liquid flows at low pressure through a runner system to fill the mold cavity. So, thereby it will completely impregnate the preform, that is the reinforcement in the process. So, that is how we prepare a reinforced reaction injection molding product. Now, once the mold cavity is filled, the plastic quickly completes its reaction. The complete cycle time required to produce a molded thick product can be as little as 1 minute. That is, the cycle time for reinforced reaction injection molding is very less, even for a thick product. So, that is one of the principal advantage why we go for reinforced reaction injection molding. Next, we will move on to blow molding. So, what is meant by blow molding? Blow molding is a fabrication process where you convert a plastic resin plus colorant or additive into a hollow container, normally a bottle. So, this process is what we call it as blow molding. Now, blow molding process makes it possible these molded products in an economical way. That is the principal reason being why we go for blow molding, and also in unlimited quantities. One can prepare hundreds and thousands of bottles in a 1 hour time or so, and also there is no finishing is required. Post finishing operations are almost nil with respect to blow molding process. Now, if you look into the basic process, it involves a softened thermoplastic hollow form, that is a polymeric resin which is melted and it becomes soft. Now, this melt is allowed to take a hollow form, and then this will be inflated by supplying an air against the cool surface of a closed mold. Once the expanded plastic comes in contact with the closed mold, it will solidifies, and then it will takes the shape of the hollow product. This is the basic behind any blow molding process. Now, if you look into the last few decades where we use these plastic products that are prepared by blow molding, the polyethylene squeeze bottles for washing liquids, that is for domestic use, and then polyvinyl chloride for bottles for cooking oil and fruit squash bottles, and polyurethane terephthalate, that is PET bottle. Almost everybody knows the PET bottle, what we normally use for drinking water. Not only that, for carbonated beverage bottles, all these are the major breakthrough with respect to the blow molding process. Nowadays, not only the blow molding is restricted to these, this also been extended to prepare toys, different types of toys for child play, and then the automobile parts and its accessories, and then more and more engineering components are being prepared by blow molding. These are the examples like the cosmetic items or the medicinal items. These are the squeeze bottles, and these are the containers, closed containers, and then the toys, and not only that, the container used for watering the gardens. So, likewise the list goes on for blow molding products. Now, there are three major types in the blow molding. One is extrusion blow molding, another one is injection blow molding, and the third one is stretch blow molding. In all these, the basic process is same, but then either we go for a extruder or we go for a injection molding machine. That is what is going to change. Now, this is a scheme showing a typical blow molding process by means of extrusion. So, the these are the stages, starting from loading the material into the hopper, and then material heating and melting that takes place in a single screw extruder, what we have seen in extrusion process. So, the single screw extruder is almost the non-separable part in the polymer processing operation, and then followed by the formation of the parison. So, this is the parison, and then the next step is the blowing of this parison with a compressed air. As a result, this will expand, and then the next step is mold cooling, and then the final is part cooling, and finally the the bottle is removed. So, this is a typical scheme for a blow molding process. The normal extrusion rate is 30 kgs per hour. So, this refers to the mass of polymeric resin that is extruded here, that is from the nozzle of the single screw extruder. So, with the 30 kgs per hour extrusion rate, one can prepare almost 257 bottles per hour of 500 ml capacity. So, that means it almost takes 14 seconds for a bottle, and if for a 1000 ml bottle, then one can prepare 225 bottles per hour, that means 16 seconds. So, that shows the economical viability of this blow molding process. That is why these PET bottles what we use nowadays are available at a very affordable cost. Next, the common features of a blow molding, either in extrusion blow molding or injection blow molding or stretch blow molding. So, these are the features. That is, the first step is the formation of a precursor, that is a hollow tube is formed, which is called parison in the blow molding terminology. Once the parison is formed, one end is closed, so that it can be inflated in the heated softened state. So, in the heated softened state itself, it will be inflated, that is, air will be supplied through to the parison and it gets inflated. Now, the inflation will continue till the parison touches the walls of the mold. So, the mold is normally at a lesser temperature than the parison. So, therefore, the solid resin will solidify and it becomes a solid product. Then the mold is opened and the bottle is released. So, these are the 4 stages. Now, looking into the extrusion blow molding process. So, starting from the extruder motor, and then you have a gear arrangement for changing the speed of the screw, then the material hopper where the material is loaded, and the cooling fans provided to ensure optimum temperature, and the heating bands used to melt the resin, and this is a nozzle. This is the typical parison arrangement. So, this arrangement is the extra when you compare it to the conventional extrusion molding. The conventional extrusion molding, so up to this is the conventional extrusion molding machine. Now, you have a from the nozzle, instead of a die or instead of a mold, what we have is a arrangement. The parison is nothing but a steel rod that is provided at the end of this arrangement. Now, this parison rod will actually, the provisions are there, this can move up and down, and then this will actually fit into this, and this is a typical mold. Typical mold, this is the hollow product. Now, you have a blown pin. So, this blow pin is an important part, because only through the blow pin the compressed air is supplied. The resin is passed through this arrangement, and once it is getting fitted in through this, then it will take a shape of this, and then this will be inflated, and then based on this mold size, the shape of the product will be. Once the product is formed, it will be further cooled, and then it will be available for dispatch. So, the deflasher is to remove the unwanted or excess product with respect to the bottle. That is, at the bottom you will seal the parison at one end, usually it is sealed at this end. So, therefore, there will be a slight polymeric melt that will sticking on to that, that can be removed with the help of this deflasher, and also at the top also you have similar, therefore, this has to be. So, the post finishing operation will be less compared to the conventional injection molding process. These are the stages in the extrusion blow molding machine. The first, the extruder die, from the die the parison, and then the first step is the mold will be at the open position, and then this is the gas nozzle, and then a parison will be formed. Once the parison is formed, the mold is closed. Now, the air is supplied in, and then this parison is inflated. As you could see, it takes a oval shape, and then it is inflated in such a way till it touches the surface of the mold. The shaded region is the surface of the mold. Once it comes in contact with that, this will solidify. So, this therefore, the final stage is the mold opening, and then the bottle will be removed. So, these are typical stages A, B, C and D. We will see that also in short. The A step is the extrusion of parison in open mold. So, when the mold is in open condition, the parison is extruded. In the stage B, the mold closes and then the parison is inflated. And the next steps C, when parison reaches the walls of the mold, it is cooled. Once it is cooled, then it is going to solidify. In the step D, the mold is open and the bottle is released. Now, the next type is the injection molding machine. It is similar to extrusion molding machine, except that instead of extrusion molding machine, you have a injection molding machine, either a reciprocating type or a plunger type machine. This will actually inject the resin into the mold. Here you have a steel rod and then the polymer is injected likewise. Now, you have provisions for the rod to get inside. According to the product size, this rod could be moved in or out, and then the next stage is passage of air to the parison, and now it is inflated. Now, this blue colored shaded region is the resin. It comes in contact with the surface of the mold. Now, it gets solidified and the product is formed. So, therefore, the only difference is instead of extrusion molding machine, you have a injection molding machine that will inject the resin straight away into the mold. So, therefore, the typical machine construction requirement is simple in injection molding machine compared to the extrusion molding machine. Now, the steps in the injection molding machine, the parison is injection molded onto a steel rod. So, that is the main difference. There the parison is formed and then inserted in the mold in a extrusion blow molding, whereas here a parison is actually injection molded onto a steel rod. Now, the rod and parison are then inserted into a mold. Now, the parison is inflated by air. This step is as usual. As it is inflated, it will take the shape of the mold. Finally, the mold opens and the bottle is released. Next, the stretch blow molding, the variation of injection blow molding in which the blowing rod extends downward into parison in the step 2. In the injection molding machine, the stretch blow molding, what happens is the steel rod that is available is allowed to stretch the step 2. Now, this what happens when you stretch means when you stretch the soft plastic, that means you are stretching it for a more favorable stressing of polymer than conventional blow molding. When it is at a hot condition, now you stretch it, now you improve the morphological properties of the polymer. That means it will the permeability property of the material could be altered. That is why we go for a stretch blow molding. The most widely used material is PET, what we call it as PET bottles, which is nothing but polyethylene terephthalate. Now, it has very low permeability and this could be strengthened by the stretching process. So, that is why PET is normally prepared by stretch blow molding process. Now, the combination of these properties makes it ideal as a container for carbonated beverages. Now, in the steps in the stretch blow molding. So, as usual, here a injection unit, this is a plunger type injection molding machine. It moves and then it injects the resin into the injection mold. This is the steel rod and also it will act as the blowing rod, and then you have a air, this blue colored region is the air wall. It is called as a one way air wall. So, that means it will allow air to pass only through one way. In the next stage, once the resin is completely filled in the mold, now this blowing rod is inserted in further, that is you stretch this polymeric resin, you actually stretch in this direction. As a result, its morphological properties are going to improve. In the next stage, now air is allowed to pass in. So, as a result, the parison gets inflated and then once it comes in contact with this mold surface, it gets solidified and then you get a blow molded product. So, this is what is called stretch blow molding. So, to summarize, in today's class we have discussed about reaction injection molding, why we need to go for reaction injection molding, some of the drawbacks with conventional thermoplastic injection molding process, how it is overcome by rim. In the rim we mainly go for reaction injection molding process only to prepare large sized particles. The syntax tanks what we normally find in an apartment, a big black colored syntax tank which is normally prepared by reaction injection molding process, And then one more variation in this is the reinforced reaction injection molding, wherein a preform is placed inside the mold and then the other things are as usual. Now, the resin is allowed to fill the completely cure the preform and then you take a product. And then next we moved on to the blow molding process. So, blow molding process is used to fabricate hollow parts, mainly this blow molding process is meant for plastic products. So, in the blow molding process we have seen three different types. One is extrusion blow molding, another one is injection blow molding, another one is stretch blow molding. So, in all these the basic principle is same. The formation of parison, inflating the parison and then removal of the hollow container. This is the basic principle, but then the type of machinery what is used is going to differ in these types of blow molding. Once the viewers after looking into this episode, these are the questions they should try to answer. What is reaction injection molding? Explain the basic process of blow molding and then state the different types of blow molding and then describe the different steps in injection blow molding and what is stretch blow molding. Thank you.